me see if my um, all right, welcome to the show, guys. Thanks for being here. I'm so excited. We have got Graham. Is it Lau or is it Law?
It's Lau.
Lau, Graham Lau. We have Graham Lau with us today. He is an astrobiologist, and you can find him. Tell everybody about yourself. What you like, what you love, where they can find you, what all the things, the awesome things you do.
Sure, absolutely, yeah. So yeah, I am an astrobiologist. I guess ever since I was a kid, I kind of like geeked out on this question of what are we? What is life in the universe? Why are we here? And it's cool because you can actually become a scientist and study those questions. And when I first went to school, I was studying biology and chemistry. I got 2 degrees there. And then I decided I wanted more, so I studied astrophysics for a while. And then I eventually jumped into graduate school and earned my PhD in geology. And so I'm kind of a mutt, I guess, of all the sciences. I've jumped around a little bit. But for those who are interested in learning more about me, you can find me online at cosmobiota.com. You can also find me on Twitter and Instagram at Cosmobiologist, on LinkedIn and Facebook at Astrobiologist. I was the original astrobiologist on Facebook and LinkedIn. And so, yeah, so I got lucky with those ones. And I'm always happy to chat online about questions that come up with astrobiology, with current missions through NASA, searching through our solar system, upcoming telescopes to look for exoplanets and try to understand if there could be life out there. And me personally, my research background in my PhD was in the realm of mineralogy and geochemistry in polar environments here on Earth, and how we can use our knowledge from these polar environments to learn more about icy worlds in our solar system and other worlds beyond our solar system. And then since finishing my PhD, even though I still do some research, I'm actually working on a book right now in the realm of trying to understand what life on Earth can teach us about alien life if it's out there. For my day job right now, I'm working for a wonderful nonprofit called Blue Marble Space. We are focused on sustainability, Earth system science, space exploration, and ways to empower scientists to become entrepreneurs and to build a better future here on Earth and beyond. And so it's a wonderful company to work for. I love the people I work with. And so it's been kind of cool. And so now I do some research, but I also now do a lot of science communication. And so you can find me online pretty easily that way.
And I do have links to his Twitter as well as his website, cosmobiota.com, in the description on the YouTube channel here. So do follow him, do check out his work. You travel a lot. You hop around and you go to different places. We already have some questions in the chat if you're up for a couple questions.
Wow. Okay. Yeah. Absolutely.
All right, learning with Suge. Hi, Suge. How you doing? Has what factors are considered in determining how best to detect life?
Wow. That's like the golden question right now in astrobiology. I'm also a part of the Network for Life Detection. We call ourselves NFOLD.
Oh, wow.
It's a new research coordination network, or RCN, through NASA Astrobiology. And a big part of NFOLD and the Center for Life Detection at NASA Ames is trying to understand this. What are the factors that make a positive detection of life somewhere else in the cosmos?
Mm.
And we've discussed this, for a long time now in astrobiology. You might know when we first sent the Viking landers, for instance, to Mars, we didn't really know what to look for looking for signs of life then. So we were looking for life very much as we know it here on Earth, life that photosynthesizes or acts like things that we have here on the surface of our planet. And now we know that that really wasn't the best way to go about it. There are other ways to look for signs of life. Things like homochirality, for instance.
Mm.
You might know that life on Earth uses one type of sugar. So
Mm.
for sugars, amino acids, a lot of molecules that are chiral molecules, that they have mirror images, the same way your left hand, right hand are mirror
Right.
images of each other. There's a lot of molecules that are mirror images of each other. But it turns out that life on Earth uses only one of the images and not both for our amino acids and for our sugars. And so a big question is that universal? Will all of life act that way? Will it select one of the mirror images and not both for various molecules in life? And so we can look for that. And then there's a lot of things we can try to understand if we see variations in molecules inside of an atmosphere, for instance, that can tell us that life is actively acting inside of a world. That could be a good way to look for signs of life. But when it comes to life detection itself, we're going to need more than just one thing. It's going to have to be more than just finding one mirror image of a molecule, or some sets of molecules working together in an atmosphere. We're going to have to find several lines of evidence to support the idea that life exists on an alien world before we can sufficiently say, yes, this is alien life. We are not alone.
I know there's been lots of different studies associated with that, and more recently, there's a new the word escapes me today. Words are hard today for some reason. But there's a new single-celled organism that undergoes anaerobic respiration, and it's just like, and it's not bacterial. It's a eukaryotic cell, something that we have not seen before. Do you have any thoughts on that
Yeah, I
particularly?
actually haven't read that paper yet.
Mm-hmm.
I've seen some of the news, some of the buzz around it. It's intriguing though, right?
Yeah.
Because a lot of life on Earth, it finds a specific metabolism, and so for instance, eukarya using oxygen for respiration is a big thing. Oxygen, when you use oxygen in respiration and combine it with other molecules, you can liberate a lot of energy.
Mm-hmm.
And so the development of using oxygen for life was a huge development on Earth. But there's obviously other ways to go about it. And so anaerobic metabolisms, are very common on our planet from a lot of organisms, and were the primary form of metabolism early
Mm-hmm.
on. And so it's kind of cool to see that there's some other options for eukarya and other organisms on our planet as well. And there's just so much that we don't know yet about the abilities of life as we know it here on Earth. Things that we are still exploring. We're still exploring and learning more all the time about life on our planet. There's still many species out there for us to learn about, discover.
Mm-hmm.
And so we definitely haven't conquered the planet. We definitely don't know everything yet.
Well, that's certainly fair. So I have a few more questions, and then we can jump into some of the misconceptions associated with that. Let's see. Paul asks, "Hi, Paul. What would be something that we might consider lifelike but not life, almost life?
Mm.
Viruses could be a thing for that.
Yeah, that's a good one. Viruses are weird, right? So
Viruses are very weird.
yeah, and right now, obviously, we're all considering viruses a lot more right now, and so maybe this is a great time for all of humanity to think more about viruses and how they actually function in our world. But we have many different potential definitions of life. We don't have a best definition or one that everyone agrees upon. And the weird thing is, viruses are one of those weird biological machines that tests our conception of what life is. And so yeah, so things like viruses are interesting, but there's also if we go out there in the universe and start finding reactions that are catalyzed through various molecules, the question is will it be life, or will it be a biological machine or a lifelike thing that doesn't actually have any way of reproducing or evolving? And even then, like, is it life? And it's a big question. There's a philosopher named Carol Cleland. She does great work in this question of, can we define life? And I think the big answer right now is no, we really can't right now. We have working definitions. There's a NASA definition of life that a lot of folks use, but even that one is questionable. And so yeah, it's kind of weird to think, what happens when we go out there in the universe and we start discovering things that just completely blow our conception of what life is.
Well, that's certainly fair. And thank you, Sage, for your super chat. Sage says, Graham Lau is awesome. Great stream.
Oh, well,
So
thank you.
thank you so
I appreciate that.
much. Graham Lau is awesome. Be certain to go check out his website. Um, Another question: what is the most likely place for extraterrestrial microbial life in the solar system? Is it in one of these are Enceladus or I'm not an astrobiologist. Is that the
No
correct
worries.
way to say that?
Most of us say Enceladus.
Enceladus. Okay, I was thinking Titan might be an option, but I don't know.
Yeah, so Titan's an interesting one, and the icy worlds of our solar system are interesting altogether. Titan's interesting in that it has this hydrocarbon rich surface and atmosphere, where we have a hydrological cycle here on Earth with water in rivers and lakes and oceans that evaporates and transpirates and goes into the atmosphere as vapor, and then rains back down or snows back down. Titan has a much different cycle, a methanological cycle, where methane is going into the atmosphere, and then radiation from the sun is causing it to break up and make ethane and butane and weird other compounds. And there's just hundreds of these weird hydrocarbons that are forming in the atmosphere and then raining out as this sludge of oily gunk onto the surface. But the surface of Titan is very, very cold. So cold that most of the reactions that life as we know it requires really couldn't even progress forward at the surface of Titan. It's so cold. And so with Titan, a lot of us, even though I think it's a good test bed for understanding how life might function in a hydrocarbon rich environment, it seems like if there could be life on Titan, it'd have to be down below the surface somewhere, where there can be a little more heat and a little more protection from that severe cold. But Titan's an interesting case. But I think right now the big ones that we talk about the most in our solar system are Mars, Europa, and Enceladus. Enceladus, many of you will know, is a very small moon of Saturn, and it's the one where with the Cassini spacecraft, when we got to Saturn with Cassini, we discovered these plumes of water erupting from the southern hemisphere of Enceladus.
That's cool.
And the cool thing was we were able to fly the spacecraft several times through these plumes of material and to study them. Unfortunately, we didn't really have the right instruments on board for looking for life inside of plumes of water coming off of the moon. We weren't expecting that. No one who developed Cassini expected to fly through plumes of water from a small moon. But we did learn a lot about it, and some research has shown, based on materials in the plumes, that there might be hydrothermal vents on the bottom of Enceladus's ocean down under its icy shell. And so that's pretty cool to think about, that there could be hydrothermal activity on the bottom of Enceladus's ocean. And then Europa is kind of in the same boat. We think Europa is not only a much bigger moon, but also has a far more voluminous ocean. There's actually so much water inside of Europa's ocean, it has more fluid, more liquid water than we have in all of our rivers and lakes and oceans here on Earth. Uh,
Wow.
so a pretty cool graphic you can find online shows a picture of all the water pulled off of Earth and made into a sphere, and then comparing that to a sphere of water from Europa, and Europa's is far bigger. So there's a lot of water there, and if Europa has hydrothermal activity, that could be a cool way for energy to be available for life if it exists inside of that ocean. And then Mars, you most likely have heard a lot about lately with us. We're now sending with the upcoming Perseverance rover, which just got its name from a seventh grader, is going to go to Mars. We were calling it Mars 2020 for a long time, but it will be the very first spacecraft since the Viking landers from NASA that inside of its mission plan is the mission of looking for signs of life. And so this is pretty big because we think there's a good chance that ancient Mars had life. It's possible even present day Mars has some form of life, and so it's important for us to go and find out. But an interesting answer to the question as well, and one of my favorites, is Venus. And so bear with me here. I know the surface of Venus is very, very, very hot.
Yeah.
You could bake one of those frozen freezer pizzas in about 8 seconds on the surface of Venus.
Yes.
But then you'd be dead and you couldn't enjoy it because it's 800 some degrees in Fahrenheit. But in the ancient solar system, very early on, if there was another place in the solar system that had life, it was most likely Venus. Venus is very much our sister planet. It's very close in size and composition to Earth, and early on might have had oceans. Very likely did, we think, and it could have had life. And it was, it's closer to the sun than the Earth is. And when the sun was a little bit dimmer in the early solar system in its history, so Venus might have been the right place then to have life in the early solar system. And so a lot of us wonder if there's any signs of life left anywhere near the surface of. But the problem is, because Venus is so hot and the pressure is so high, it's so hard to get any spacecraft there and do any research.
Yeah.
But I think it'd be pretty groovy if we could find some really old rocks somewhere on the surface of Venus, underneath of all that cataclysm and heat, and discover some signs of ancient life there as well.
That would be cool. And I think a common misconception, particularly with Venus, is that, oh, it's hotter because it's closer to the sun. No, it's hotter because of all of the greenhouse gases in the atmosphere. So,
Exactly, yeah. And Venus is an interesting case for us to understand climate change, and
yes.
was an interesting way for us to start understanding our own climate here on Earth, and that planets can warm, and it can happen not only drastically, but it can become irreversible, where you
Yes.
have the atmosphere itself becomes such a thick blanket that the warmth starts creating a thicker blanket, and you just have this runaway greenhouse effect. And so, yeah, so Venus is a very interesting case. It's very warm.
It is. Oh gosh. We have another question. Do you think non-carbon based life forms are a possibility? Maybe with silicon, you think?
Yeah, silicon's the big one that we talk about. If you look at the periodic table, carbon, just below carbon, is silicon.
Mm-hmm.
Silicon can also make 4 bonds. It can also make little branched chains of silicon atoms. We've used silicon to make computer chips and things like that. And so science fiction authors for a long time have wondered, will we find a silicon-based life form out there? And I think it's possible.
Mm-hmm.
But the interesting thing with the chemistry is that the bonds between the carbon atoms are much stronger than
Mm-hmm.
the bonds between the silicon atoms. And so when it comes to life, it seems that it'd make more sense for life to use carbon instead of silicon. And we can't really think of a situation where a planet would have just that much silicon and no carbon at all, for life not to have used carbon. But it's possible. And the fun thing about astrobiology and about asking questions about life in the universe is just, you can always just toss out, yeah, it's possible, but we just don't know. But I think it'd be interesting if we go out there one day and discover some neighbors, some cosmic neighbors next door in a solar system nearby us that are using a different basic structure for their chemistry. And so
Mm-hmm.
silicon as a backbone for molecules could be a really interesting one.
That would be pretty interesting. Okay, I guess we have a few more questions. People are really excited. They're like, "Oh my gosh, I have all these questions." So that's
Yeah,
always nice.
life is groovy. It's cool to question, what is life? Why are we here? These are huge questions, and there's so much to learn.
Oh, there are. Let's see. We've got one from Renee. Hi, Hi, Renee. Hope you're doing well. Is it true that the moon was struck by us with an object and it rang? If so, what does that mean?
I'm not quite sure what the question means.
Yeah, I'm not quite
Um,
sure with that
I'm
one.
wondering if what you mean is was the Earth struck by an object that created the moon,
That might have
um,
been what
which is
the
our
question.
current understanding. So there have been a lot of hypotheses through time in how the moon formed. And then some of those ideas were that the moon came from somewhere else in the solar system, had formed as a small world, and
Uh-huh.
got trapped by the Earth. One idea was that the Earth was spinning so fast early on that it basically spat the moon out as a small rocky body. But the current best understood and most accepted theory for how the moon formed is that there was a moon forming event, as we call it,
Mm-hmm.
where an object roughly the size of Mars, based on current models, which is called Theia currently,
Mm-hmm.
struck the Earth at kind of a glancing blow. And in that process, a lot of its metallic, really dense core material sank down into Earth's core,
Mm-hmm.
which is part of why the Earth is very dense. It's one of the densest. It is the densest planet in our solar system, and we think that has to do with the fact that the core from this ancient world sank into us and basically joined our core. And then a lot of the lighter material at the surface of our world, as well as that planet, that world Theia, blew off and then accreted together and formed our moon. Uh,
Mm-hmm.
and that's currently the best understood theory for how the moon formed. It's based not just on modeling, but also on the chemistry of the rocks that were brought back from the moon from Apollo. And so we have a good understanding of that right now, and it seems to fit really well with our current models. And so it seems most likely that that was the case, that Earth was struck by another world. And it's interesting. It kind of brings us a little bit to that definition of planet right now. That's been a big thorn in a lot of folks' sides because of Pluto and some other issues. And I, for one, am not a fan of the current IAU or International Astronomical Union's definition of planet for other reasons. Um, but one thing that a lot of people don't know is that very early in our solar system, we most likely had a lot more than just 8 planets and a whole bunch of dwarf planets. There were most likely hundreds, if not thousands, of worlds, all flying around each other and some of them crashing into each other. And our current models tell us that giant planets like Saturn and Jupiter migrate in the early solar system. And if that happened, that probably kicked some of those planets or worlds out into the outer solar system or out of our solar system altogether. And so I would love to go back to the early solar system and just have a look at what was happening with all these worlds flying around and crashing into each other and getting tossed away. And it must have been just chaotically beautiful.
I imagine so. Early universe was quite chaotic, from my
Yeah.
understanding. So,
Yeah. We're born from chaos.
which is strange, but also poetic. You know.
Hmm.
Yeah.
Indeed.
All right. So, some more questions. Here we go. How plausible? This comes from Paul on Periscope. Hey, Paul. How plausible is panspermia? Could life survive space, then succeed somewhere new?
I love it, Paul. So panspermia, as a question, really is one of the things that kind of brought me into astrobiology as a career. So I was an undergraduate student studying biology and chemistry. And admittedly, like I always had this thing in the back of my head that I wanted to know more about life. I loved Star Trek growing up. I loved Carl Sagan. I wanted to know more, but I also was thinking about a job as an
Right.
undergrad. And so originally I wanted to do pharmaceutical work and work in biotech. And then I had a course in ecology and I had to do a project on panspermia, which I self-selected. I thought it was a cool idea. And that project kind of made me decide to change and just stick with what I really wanted to do, which was astrobiology. So panspermia, for those watching, if you haven't heard this term before, there's a good chance you have, but if you haven't, panspermia basically means seeds everywhere.
Yeah.
And it's this idea that's been around for quite some time. Anaxagoras was the first to come up with the term. And this idea that could these rocks raining down on Earth from space as meteorites, could comets and asteroids that hit the Earth, could they be bringing life along with them?
Mm-hmm.
Could life have been transferred from early Venus, if it had life, and transferred to Earth? Did life start on Venus or did life start on Mars and then come to Earth? And these are really important questions that aren't just in the realm of science fiction. There's a lot of science behind this. people have now done a lot of work trying to understand, could life survive an impacting event? So when a large impactor, say an asteroid, strikes a planet, in that process, sometimes if there's enough energy, some of the rocks that are struck can be shot back up and actually have escape velocity and leave that world. That's how we get meteorites from Mars, for instance, here on Earth. And so, could that be a way for life to then leave a world, be transmitted inside of rocks through space? And our current understanding is that yes, it seems quite possible that life could survive inside of materials and be sent through space, and then potentially could inoculate another world. Um, it's also a good reason for us to go to the moon again and get a lot more moon rocks. There's a good chance that there are rocks from early Earth and early life from early Earth that were trapped inside of these rocks, that we can go and study on the surface of the moon if we get our butts back there. But there's a lot more to understand about panspermia and whether or not it's possible for these seeds of life to be transmitted through the cosmos. When it comes to whether or not life could have come here from another solar system, another star system, or another galaxy, it actually starts getting a little more complex then, because of the distances between stars, especially between galaxies. It's highly unlikely for a rock to have transferred from one galaxy, say the Andromeda galaxy, to our galaxy, to come here. It's just such a long distance. The amount of time it would take, even moving at what we call hypervelocity. Rocks, worlds moving through space are traveling quite fast, but even then, it's a long time to get between intergalactic space.
And you have
As
all the
far as
elements associated with that, the radiation and,
oh yeah,
the collisions, that could
yeah,
happen.
the odds of something coming here are very low, but not impossible. But it seems unlikely. But there are star systems close by to us. We have a lot of close neighbors. There's Proxima system and Bernard Star and some other star systems nearby that are close enough that a rock could have transferred from one of those solar systems to ours. A lot of folks might recall Oumuamua, the interstellar object that came into our solar system and has been flying out of our solar system rapidly here lately. And we've now seen a second interstellar visitor, we think, as a comet. And chances are, through the history of our solar system, a lot of objects from outside of our solar system have come in and flown near us. And so it's possible that life could have come from another solar system. But even then, we still have vast distances to consider. And that means that if that happened, life would have had to have started a very, very long time ago there.
That's fair enough. Yeah, I think the biggest thing is getting here, distance, and everything else that could happen to it on its way here. Okay. Let's see. I think. Oh, Kid Kelly said a cosmic mosh pit. I guess early universe, a cosmic mosh pit. That's right.
That's a really good way to describe the early solar system.
Michael, hi Michael. He says, when they find a planet in the Goldilocks zone that's 4 to 5 times the mass of Earth, they never mention the bone crushing gravity. What's the effect on other life?
It's a really great question. First off, thanks for saying Goldilocks zone and not habitable zone. I really appreciate that. It's weird. Yeah, there's lots of these very large super Earths or mini Neptunes, we call them out there. These large worlds. And you're right, we don't talk about the gravity very much, but life here on Earth evolved in Earth's gravity. And so we have no reason to think that life on another world couldn't evolve to adapt to that gravity. And so if life starts in a world that is 4 or 5 times the mass of the Earth, while there would be more gravity, it'd be higher than 1g, life that would originate and evolve in that kind of setting would adapt obviously to that gravity. And so even though it might be bone crushing for us, for mammals, vertebrates here on Earth, that have grown accustomed to our 1g, organisms in that world really shouldn't have a problem with it. I think it becomes, when you start talking about gigantic worlds, Jupiter-sized worlds, things like that, at that point you start having a lot more gravitational issues. Of course, worlds of that mass are icy worlds, are gas giants here in our solar system and so far elsewhere. Um, but yeah, it's an interesting question, right? Like, what if we find life and it's adapted to a much heavier gravitational regime? Could we actually bring that life here and study it? Maybe not. Maybe that life wouldn't do so well
Yeah.
at a lower gravity, the same way that we wouldn't do so well at a much higher gravity. It's hard to say.
Yeah, and one of the issues I know associated initially when we were trying to get to Mars is the effect of a microgravity environment on the human body, and we got a bit more information from that with the twin studies. Um, and so I one thing that I found was particularly interesting is that the twin that was in space, a lot of the expression of certain genes shut off due to the lack of gravity. I can only assume that that would be it because they were active prior to him going into the International Space Station. And now I haven't checked to see if they've checked to see if it's turned back on again, this particular gene expression or not. I haven't checked on any updates on that. Do you have any thoughts on that?
So the twins you're discussing are Scott Kelly and Mark
Yes.
Kelly. Scott Kelly spent a year in space, and so researchers at NASA have been studying them both to understand what the differences were after one of the twins spent a year in space. Unfortunately, one twin study really isn't enough. We could use
Mm.
so many more. It'd be great if some other twins could volunteer and we could fund them to go and do some more studies and try to better understand what's going on to the human body in microgravity. And we should clarify, it's not a lack of gravity. At the International Space Station, it's about 98% of the gravity that we have here on the surface. So it's still a lot of gravity. It's just this apparent weightlessness
Yes.
that happens because the astronauts are falling at the exact same rate as the space station around them. And because of that, it feels like there's no gravity on our bodies. And for organisms like ourselves that have evolved over such a long period of time, uh, and have been adapted to this gravitational regime here on Earth, to go into that apparent weightlessness situation is very strange for our bodies. And there's a bunch of folks out there doing some really awesome work trying to understand bone growth, bone decay in space, what happens to organs, what happens to things when the blood's flowing. For instance, astronauts, when they first go to space, they lose their sense of taste for a little bit. Not entirely, but a little bit, because all the blood starts pooling and all the mucus goes up into their sinuses, and they kind of lose their sense of smell a little bit, and so they can't taste things as well, which is kind of weird. So a lot of food is overly spiced and overly sweetened and things like that for astronauts. And so the question, if we do send humans to Mars, and they have, let's say, a 6 month trip between Earth and Mars, and then they spend maybe a year and a half on the surface, and a 6 month trip back, what's going to happen to their bodies over those long periods, and leaving alone radiation and all these other potential things that could happen, just the apparent weightlessness alone during the transit, and then having to step out of their spacecraft on the surface of Mars, which has 1/3 of our gravity, and do work after having that apparent weightlessness for a long time, and then coming back here again. It's a big question right now. What will happen to their bodies? What will happen to their bones? And so we're doing a lot of research right now. A lot of folks working in aerospace engineering in the realm of bioastronautics are studying, the human response, the human body's response to microgravity, to the space environment.
That's pretty cool.
Yeah.
All right, I think we've caught up on the questions. Let's jump into misconceptions. What is a common misconception that you hear that it can drive you nuts or not? It didn't, just a common misconception that you hear in your discussions and when you interact with the public.
Well, there's so many. I mean, so I've done, a lot of, I've given lots of talks. I've gone to museums. I've shared science with lots of groups of people, and I think people are really interested in whether or not we're alone in the universe, and I love it. I love talking with people about this. But one thing that happens a lot is people have heard, through the news and through science fiction, about this idea of alien visitation, that aliens are here now or have been here in the past, and it's a really cool idea. It's really fun, but there's literally no evidence whatsoever that aliens are visiting us right now. And it's kind of a sign of the times that a lot of people think that our world governments are aware of aliens that there have been aliens at Area 51 and things like this. Um, and that interestingly shows a lot of hope from those people about the ability of governments to hide things when they're not usually so good at that. It means having a lot of people be involved in a very large conspiracy, just like the moon landing. There are still people out there who think the moon landing was a hoax, that it wasn't real, and interestingly, those people have a lot of faith in the management of hundreds of thousands of people to tell a lie, which it's just most people aren't that good at it. One person would have to blab. So when it comes to alien visitation, it's such a cool idea. I love the Stargate franchise of science fiction shows and the original movie. It's so fun to think about what was human culture influenced by aliens visiting us from space. It's a fun idea, but we have no reason to think it's true.
Right.
And so I get that a lot when I have conversations with people. They want to know, like, do us astrobiologists have an inside scoop to the aliens who are hidden at Area 51? The thing is, like, chances are, if we do find an example of alien life, even microbial alien life, the potential benefits to our understanding of biology and biochemistry will be so remarkable. That would definitely filter into our technology and our civilization. And so it'd be hard, I think, for a government to have some alien technology and alien biology and not advance rapidly.
Right. And that would be it would be hard to hide that.
Yeah.
I can't imagine. And the people who tend who tend to perpetuate that type of idea are people that don't really look. They tend. I'm trying to say this in the most delicate way possible without. They tend to not be very. Oh, I just better not say it. Like they tend to not be very good. See, words are hard today because I don't want to say something not nice. So, but they tend
Yeah.
to not be very good representatives of the community where they would have extensive amounts of knowledge on the thing. How about that? That sounds all right.
I'd say yes and no. I'd say many of them, but I've met some people who are very well educated, who have spent a lot of time in their lives reading and trying to understand, who still want to believe. If there are any X Files fans here, Mulder had that poster that said "I want to believe." It's
Yes,
been
yes.
replicated now through history, has become a meme online. And I agree. I want to believe that we're not alone. I want to believe that there's more going on out there in the universe, and that we're not just some weird special case.
Mm-hmm.
I want to believe that there's more to life as we know it, and it's just waiting for us to find it. But more important than that want to believe in these things is the want to know, the want to understand whether or not it's true. There's a lot of really cool ideas in history that we can want to believe in. I absolutely love the mythology of Santa Claus. But I also know that Santa Claus doesn't really exist. It's still fun to think about, though. And so I think the same thing with alien life. It's really cool to think about this idea that aliens could have visited us, could have somehow impacted ancient civilizations. And while I would never say it's impossible, I would say it's highly unlikely. At
Right.
least we don't have any evidence to support it. And so if you want to believe, that's fine. But you have to understand that there's a difference in believing in something and actually having the material evidence to sufficiently say it's true.
Yeah, well, that's certainly fair. Okay, so far we've talked about. Gosh, We've taken lots of questions. We have another. We have a couple more questions. Actually, we'll give that a go. Let's see. We have one from Nether. Hey, Nether, how you doing? Hopefully my sound is fixed. I don't know what it is. Sometimes my computer's like, let me pick your worst microphone. And we're going to go for that. And then all of a sudden I have to go back and reset settings, redo them. All right. So Nether says, my question is what things are the chance we find non-oxygen, okay, I get non-oxygen breathing multicellular life on another world. I think we kind of touched on that a little bit. Anaerobic stuff was the way to go initially on our earth, and now we're finding eukaryotic cells that are undergoing a type of anaerobic respiration. So that probably is our best chance on finding something, I would think. What do you think?
It seems that way based on the energetics. So the way that it works, so anaerobic respiration, this respiration that doesn't use oxygen, these organisms are breathing other things and respiring other things. But for us, once life learned how to use oxygen, there's just so much energy that oxygen can liberate when it's used in respiration that it'll really was part of what we think allowed life to become multicellular and to grow up the way it has. However, that doesn't mean that life necessarily required oxygen to become multicellular. It might have been a boost for life here on Earth, but maybe we'll find life in another world where that single evolutionary adaptation of using oxygen in such a way never happened. Or maybe life will have found, other things that we don't use currently here at all for life on Earth. And so it would be interesting if we find some multicellular alien being that breathes in other materials and breathes out other materials than oxygen and carbon dioxide and things that life here on Earth uses. And so I think it's quite possible, honestly. But when it comes down to it, it really is about the energy that's available through these reactions. So you eat a candy bar and you take all this sugar and all this material in, and then your body is using the oxygen that you're breathing in, combining it with that material and liberating energy in this process, and then you're breathing out carbon dioxide because of it. And so that energy liberation is really what is allowing our bodies then to work, to pick up a barbell or go for a run or play guitar or jump. And so because of using oxygen mixed with these things that we're eating, it's allowing us to do that, and it allows us to do it really, really well. There's a bunch of energy coming off of these reactions. And so even though we think life probably follows a lot of similar characteristics, it's quite possible that there are other ways to do this too that still provide enough energy to do those things.
That's certainly fair. I'm particularly interested. I know there was a study, and when we're getting into like macromolecules and building from smaller, basic compounds and then building on top of that, there was a paper that came out, I think a few years ago. I think NASA picked it up or something, on how they were hoping for, they had taken a lot of the different organic compounds that they found on Titan and then put it under similar conditions, and saw that they were making their own chains and their own crystal structures, to where they were building on top of each other, similar to like what we would see with amino acids, with proteins and things like that. So it's kind of neat to see these types of experiments coming out, and people are kind of playing around with that to see if we can build macromolecules from these basic molecules that would lead towards, at least single cellular life. I mean,
yeah, it'd be very cool to find that. And the paper you're mentioning, I think might have been the one written by my friend Morgan.
oh,
You can
okay.
find her on Twitter at Stars Are Calling. Morgan Cable is a research scientist at NASA's
Mm-hmm.
Jet Propulsion Laboratory. She specializes in studying icy worlds, the geochemistry, geology, and mineralogy of icy worlds, as well as working on spacecraft to better understand if life could be out there in Enceladus, for instance, or other places. And she was involved in some of the research in first finding a potential mineral analog that could
Mm-hmm.
exist on the surface of Titan or will exist on the surface of Titan. And so it's very interesting research, especially when you have these environments. Like Titan is very different than the surface of Earth. And
Yes.
so the geology is going to be very different as well. And one cool thing that we don't talk about enough, I think, so a scientist named Robert Hazen has done a bunch of research on the mineral evolution of worlds, especially as tied to life. So currently, we only know of a couple hundred minerals on the surface of Mars, whereas here on Earth, there's over 3,000 known minerals on Earth. And so Robert Hazen and his undergraduates, graduate students, postdocs, other people doing research with him have been studying the history of minerals on our planet. And if we look, in the very early history of the universe and the history of our solar system, there were just a few very simple minerals that could have existed. And then once our Earth forms, once we have planets forming, we can make a bunch more minerals. But then after that, the big evolutionary steps as far as minerals are concerned come on the backs of life. So life, going through its large transitions, for instance, utilizing and producing oxygen was a huge transition for life on Earth. And putting all this oxygen into the atmosphere also changed the geology of our world. And so you start having all these minerals form that have lots of extra oxygen inside of them. And so it's really cool research that Robert has done trying to understand the mineral evolution of worlds and whether or not we can just look at the mineralogy, the mineral set available on the surface of a world, and whether or not that would tell us if life is present.
This is all fascinating. We could probably talk forever about this sort of thing.
It's cool stuff. I can go on forever. Geology and biology and chemistry related to life. There's just so many cool things to understand.
There really are. Okay, another misconception that you might have heard. We hear the aliens. It's got to be aliens. What's another misconception that you hear often?
So one that I do want to discuss, and it's one that I personally write about a bit, is this idea, and we mentioned this earlier for one of the questions, is this idea of a habitable zone. So I think it's unfortunate that a lot of astronomers continue to use this term. So habitable zone doesn't mean anything about habitability at all. It doesn't say whether or not a world inside of that zone is inhabited by life. It doesn't say whether or not a world in that zone can be inhabited by life as we know it. The term comes from this idea of the Goldilocks zone. This idea that there's a zone around stars where liquid water could exist at the surface of a terrestrial world. So if we have a world that is terrestrial, it's a rocky, metallic world. If it's inside of this zone, it's not so close to the star that it's overheating and losing all of its water into the atmosphere so far away that all the water should freeze. Instead, it's in this area where there can be liquid water standing as oceans and rivers and lakes at the surface of the world. But even then, being in that zone for a terrestrial world does not mean that that world will have standing liquid water. There's a lot more to it. It has to have the resources. It has to have the water present to allow that. It has to have the right atmosphere to allow that to happen. And so there's so much more going into it. And so I personally prefer the term Goldilocks zone, even though it does refer to a fairy tale in Earth's history. I kind of like that. I like that we can incorporate some of our cultural history into our words that we use about science and our understanding of the universe. And Goldilocks is a very basic tale about things being, too much in one direction, too much in the other, and finding a happy medium. And so I kind of like using that term. I really don't like habitable zone, because my personal feeling is that when we say that we found another exoplanet in the habitable zone, a lot of people think that that means that this is a world that can be inhabited by life as we know it, and that simply isn't true. And so for me, I honestly think we need to get rid of that term and stop saying it. Habitability is very important for us to understand, to study, and we should be studying whether or not there are worlds out there that life as we know it can survive on, or life in general. So some form of life could survive. But the term itself is so misleading. I think it should go away.
Well, and that's kind of one of the things people, particularly the general population, they get terms mixed up and wrong when we get into theory, law, all of hypothesis. So to use something that's habitable zone, I completely agree that if it's, people will see that and go, oh, life can live there. Well, no. And then you go through and you have to explain all the things why, so terminology is particularly important when you're
really
dealing
is,
with
yeah.
the population.
It's like the word planet right now we've been having some issues with. So some of you might know Mike Brown. He's an astronomer in Caltech. He's one of the ones who's discovered lots of these other worlds in our outer solar system. And the discovery of Eris in 2005 is really what forced us to go back to the drawing board and revisit the definition of planet. And honestly, Pluto had been in question for a very long time. It's not like a bunch of people got together and were like, we hate Pluto, we're getting rid of it as a planet. And Pluto still is a planet. It's just a dwarf planet is the new term that's used for these worlds. But the definition itself is terrible, in my opinion. So, for those who don't know, in 2006, the International Astronomical Union held a vote uh, for this new definition of planet. And the definition has three parts really. So the first part is that a planet has to orbit the sun, and I'll come back to that here in a second. The second part is that a planet has to be sufficiently massive enough. It has to have enough material that forces of gravitation cause it to pull itself into a spherical object, or to an oblate ellipsoid like our planet is, but spherical roughly. And then the third definition, which is where Pluto failed, and it was how we could make Pluto a dwarf planet instead of a planet, was that a planet has to clear its orbit of other debris. So you might know that there are near-Earth objects that are in orbit with Earth, but there's not many of them. Their mass, if you put it all together, is a very small amount compared to the mass of Earth. Jupiter, in its orbit, has a bunch of asteroids both in front of it and behind it, trailing it as it goes around the sun. But those asteroids, if you took all the mass of all the material in Jupiter's orbit, all that material together is almost nothing compared to the mass of Jupiter. But for Pluto and other dwarf planets, so for Pluto, for instance, inside of its orbit, it's going through the Kuiper belt. And so there's so much other material that when you get all the mass of that material together, it's a lot compared to Pluto. And so that's how we made Pluto a dwarf planet. But as others have pointed out, like Alan Stern and David Grinspoon, it's a weird definition because it suggests that at a certain point in our solar system, the Earth wasn't a planet. Because very early in our solar system, with our cosmic mosh pit happening and all these worlds bouncing around and all this debris, the Earth hadn't cleared its orbit and probably hadn't for quite some time. In the first maybe 10 million, 100 million, I mean, there's probably a very good period of years where the Earth hadn't cleared its orbit. And so was the Earth not a planet then? Even though it was exactly the same, mass as it is now, roughly. And so it's a big question, right? And also that definition, again, changes for all kinds of other worlds through time as more material moves in and out of the solar system or around them. And then my personal issue with that definition comes back to that first part again, that a planet has to orbit the sun. We've now discovered thousands of exoplanets, confirmed detections of exoplanets, worlds that are planets around other stars, and yet the current definition of planet doesn't allow us to actually call them planets, which I find absurd. And so I think we need to go back to the drawing board with the definition and get our words right as we figure it out. But I also don't think we should do it just because people feel bad for Pluto. There's a bunch of other reasons to do a better job.
Yeah, yeah. There was quite an uproar about that amongst the populace. And thank you
Yeah.
for the super chat, Kid Kelly. He gives a thumbs up, saying "Good job." Yeah.
Yeah, and for those who are interested, Mike Brown and his colleague Konstantin Batygin, they put out a paper a little while back hypothesizing that there might actually be another planet that's much larger than Pluto, maybe even larger than the Earth by a good bit,
Yeah.
in the outer solar system. They created this hypothesis based on the mathematics of gravity. A lot of these objects that we're now finding in the outer solar system, like Eris and all these other objects out there, based on how they're orbiting the sun, it seems like on the other side of the sun, there should be some other massive object out there. Kind of like, a teeter, basically, with a fulcrum in the middle as the sun. There's a bunch of weight on one side, and so there should be something else over here to balance it out.
Right.
And so they hypothesized what they call Planet 9 out in the outer solar system. Some who love Pluto so much are calling it Planet 10. But they've also hypothesized where we should look at if it's out there. And so they've been looking using telescopes, and it'd be pretty cool if we actually did find that there are other planets, other worlds that are, large objects out there in the outer solar system. that are just so far away that we couldn't see them before with our
Right.
telescopes.
Goodness. We're coming up at almost an hour. Let me see if there's any other questions. If you guys have any other questions, really quickly pop those in. Scrolling back through. Well, from Renee, have you ever come across anything you haven't been able to explain yet?
Ooh, that's a great question. Absolutely. That's part of being human. No one person knows
Yeah.
everything. If you meet someone who knows everything, ask them if they know everything, and they're going to have to say, I don't know. It's just the basic answer, right? And so,
Mm-hmm.
uh, those of us who spend a lot of time studying in a specific field or a discipline, even though we become very, very good at understanding some
Mm-hmm.
things, no one's an expert at everything. And so there's a lot in the world that I don't understand, that I can't explain well. Um, and honestly, when it comes to our understanding of our place in the universe, science is a tool that we use to better understand who we are, what the world and the universe are around us. And so far, the tool of science has been the best tool we've ever developed for better understanding ourselves in the universe.
Mm-hmm.
Now, that's not to say that science won't change. Science has been changing through time. There's never been like one set, tool of science. It's a thing that morphs and evolves by itself. And chances are, what we call science right now might be much different in 100 years or 1,000 years from now. But it allows us to understand a lot about our place in the universe. That said, there's a lot that we just can't explain very easily right now with science. For instance, trying to understand what life is pretty hard when you can't define it to begin with. Um,
Mm-hmm.
there's this idea of the pornography definition of life, right? I can't quite recall right now. You guys can look this up. There was a Supreme Court justice who had basically said of pornography, I can't define it, but I know it when I see it. It's kind of true of life, right? Like, we kind of know what things are alive here around us, but when we start kind of going to the fringes of that, it gets a little difficult. Things like viruses, biological machines, prions. There's a lot of things that start making us question, what do we actually know about life? And so understanding what life is hard. And when it comes to that, understanding what consciousness is even harder. We don't
Yeah.
know what consciousness is. There's currently this idea of panpsychism, that consciousness is this thing that pervades the cosmos and is all around us, and that the way our brains evolved allows us to tap into whatever consciousness is. There's a more reductionist, a more materialist approach to it, that consciousness comes from our neurons, comes from inside of our brains. But both approaches don't tell us still what consciousness is.
Right.
And it doesn't tell us whether or not, my dogs, I have two huskies, I love them so much. I can't know if they have consciousness the way that I have consciousness.
Yeah.
And so there's so much that we just can't explain yet. Science allows us to approach an understanding of some of these things, but doesn't allow us to fully explain it yet.
Mm-hmm. Well, I mean, that's certainly fair. And then once we get enough evidence for a particular thing, we can piece it together and come up with this is our explanation, which is when we get to theories. This is
Yeah.
how we explain the particular thing based on the body of evidence, what we have. Well, we've come up on an hour. This has been absolutely amazing and so much fun. I really appreciate you taking time out of your Sunday to come and hop on here and take questions and chat.
Yeah, it's been great. Thank you so much for having me on. Honestly, the rest of my day is playing Fallout 4 and thinking about what's going to happen here with coronavirus. So,
Well, tell everybody where they can find you one more time. And there are links to his website as well as his Twitter in the description on YouTube. So please check that out.
yeah, please, you can find me on Twitter, Instagram, at Cosmobiologist. I'm always happy to chat about everything. Life is groovy. The universe is cool. Space exploration is my jam. And so I love talking about these cool things. Also, the philosophy of science, the philosophy of astrobiology, trying to understand these things is a huge endeavor. No one person alone is ever going to understand everything. We have to work
Mm-hmm.
together to develop our understanding of it as a civilization. And the best way to do that is to have conversations just like this. And if you guys want to reach out to me, I'm always happy to chat and talk more.
Awesome. Well, thank you so much, guys. Please do click on the links. Go check out his website. Give him a follow on Twitter. Love to have you back again whenever you find time.
Yeah,
And
great.
guys, this has been awesome. And if you have any other questions and you can't find him, just drop them in the comments and I'll send it over to him and see if he can get you an answer. So, all right. Well, thanks again for being here. I guess we'll sign off for now. We'll see you guys next time.